In this video, we're going to be going over AI for everyone, and this is our part 3 video inside of this series. And specifically inside of this video, we're going to talk about what data actually is. So let's get started with this video. So first of all, what is data? So let's look at an example of a table data, which we can also call as a dataset. So if we look at our right here, you can see that there's a picture that contains a table of data or a dataset, and inside of the left column, there's the size of the house, and on the right column, the price of the house is there. And you might decide that the size of the house is A, and the price of the house is B, and have an AI system learn this input to output, or A to B mapping. So basically what we're seeing here is that inside of this table of data, we can create an actual model. So let's just say we give the house in square feet to the model, and once we feed the model the size of the house, then the model is automatically going to come up with a price range for us. So this is called A to B mapping, or also machine learning. And if you want to learn more about this, we already covered this inside of our last video. So if you want a deeper understanding, you can also watch our part 2 video out. So in summary, this is a short example of how you can explain what data is and what A to B mapping is. So now let's see how we can define inputs A and outputs B. So let's look at an example of another table or another data set on our right again. So let's just determine which one is going to be our inputs and which one's going to be our output. So here we can see this time we have 3 different columns. The first one is the size of the house, the second one is the number of bedrooms, and the third one is the price of the house. So obviously we can tell that the inputs are going to be the size of the house and also the number of bedrooms, and our output is going to be the price. So this basically means if we have a model and if we provide the size of the house in square feet and then also the number of bedroom it has, then our model would give us an estimated price range of how much it would cost. And once again, this is another example of A to B mapping. So now since we know what A to B mapping actually is, and we know how we can define inputs A and also our outputs B, let's actually look at how we can provide a model with data and then actually get accurate results based on the model providing our inputs A and getting our output B. We're going to call this as acquiring data. So basically what you have to do is you have to provide the model with tons of data. So if you give the model tons of data of a certain thing, then the model will actually be able to understand and then spit out a response after that. So for example, if we go back to our previous slide, if we take the same example of the size of the house and the number of bedrooms, in order to make this more accurate, what we would do is based on the area that you're living in, what you can do is you can gather up the size of the house, and you can also gather up a ton of data about the number of bedrooms and also gather up the price of the house that you selected. And after that, what you can do is you can train the model so that when you press search based on the size of the house and based on the number of bedrooms, then it's going to respond with a price. But in order to make this accurate, you need to have a ton of data. So here, if we come back to this slide, manual labeling is basically from all of the data that you collect, you have to manually label which one is correct or not. So for example, let's just say in this case, we're trying to create a model that is building a cat detector. So basically when we provide the model with an image of an animal, it's going to respond with if it's a cat or if it's not a cat. So for example, we're going to provide this image and it would say that it is a cat, so we have to manually label which one is a cat or not. So for example, if we look at this one, this is not a cat, this one is a cat, this one's not a cat, and then we have to keep on going and we have to keep on manually labeling all of the images that we provide to the model. That is how you can create a model for building a cat detector. And also just keep in mind if you're going to do that, so just here we just showed an example of 4 different images, but in reality, if you're actually trying to create a model that can provide you with the correct answers, you're going to need hundreds of thousands of pictures of different animals, different cats. Like for example, the model might get confused between a dog and a cat, so you're going to have to provide it with tons of different images so then it will finally understand. And the more data you provide, the more accurate your model will be. So this is basically one way of how you can acquire data. So furthermore, in acquiring data, let's observe the behavior inside of this image on the right here. So if we look at this image probably refers to some type of machine like a laundry machine or a dishwasher or something like that, because it talks about the pressure. That's probably because of water pressure. It also talks about the temperature of the machine and if it's at fault or not, and also the ID. So we can obviously see that the inputs of A is going to be the ID because we have to provide that. and then we also have the pressure and also the temperature, and then our output B is if it's at fault or not. So basically our inputs based on the pressure and based on the temperature, are we getting an output of a fault, yes or no? So there's a machine ID, and there's the temperature of the machine, and there's pressure within the machine, and then did the machine fail or not. So now we're going to talk about how you can actually acquire data and how you can make your model or your application to run. So instead of manually doing this all, you can actually download the data from the internet. So thanks to the open internet, you can freely download some information or data, and ranging from computer vision or image datasets or self-driving car datasets, you can find basically any type of data you want on the internet. But just keep in mind that some of them are free, but some of them are also used in licensing and copyright, so you might have to consult with the owner if you can actually use their data. And here are some of the steps that you can use to download the data from the internet. So step number 1 would be the user request. The step number 2 would be the DNS lookup. The step number 3 is the server connection. Step number 4 is the HTTP request, and step number 5 is the file saved. And you can read the description on your own if you are interested in downloading data from the internet. So in conclusion, this is how you can get data for your model if you are planning to build one. So now we're going to talk about the common use and some misuses of data. And we're going to use an example of the IT company and also an AI company. So as soon as you start collecting some data, go ahead and start showing it off to an AI team. So I'm going to explain an example of, let's just say that there is a home builder, and this home builder is trying to create an application. So where you provide the square feet of a house, you provide the number of bedrooms, the bathrooms, and then it responds with the price of the house. So let's just say that you started collecting some data and you want to create that application, so you have to immediately go and consult with an AI team. Because often the AI team can give you feedback on your IT team on what types of data to collect and what types of IT infrastructure to keep on building. So sometimes what happens is, if we take the same example of the home builder, if they have all the data already done and then they give it to an IT team to create the actual application, so sometimes the information might not be reliable and it's kind of useless. So the AI team doesn't need it. As soon as you start collecting data, make sure you consult with the team so that they can probably give you some suggestions on what to do. So this is just some common use and misuses of data. So further expanding on what I said, so hey, I have so much data, surely an AI team can make it valuable. Well, unfortunately, this doesn't always work out because more data is usually better than less data, but we wouldn't take it for granted because just you have many gigabytes or terabytes of data, it actually has to be reliable information. Just as another example, if you're writing an essay, a student could have about 1,600 words on their essay, but another student could have only 600 words on their essay. But the one that has 600 words on their essay actually wrote perfectly, and they summarized everything with important information, while the person with 1,600 words, they just wrote random stuff that came to their mind. So it just relates to this because the more data you have, that doesn't really mean that it's valuable. You need to have valuable data instead of more data. So that summarizes the common use and misuses of data. And now let's talk about how data is actually messy. So sometimes what happens is when you collect data, there's always going to be some type of inputs inside of the data. For example, in this square root of house, there's an unknown value. There's the number of bedrooms, it might be unknown, and sometimes you might even mess up on just the numbers. This is even less than 1 cent. So we obviously know that the price is not going to be less than 1 cent. And yeah, so sometimes data can be messy. So sometimes you have incorrect labels or just incorrect data. So this house is going less than a cent, which just obviously means it's not right. And data can obviously get messy like this, so sometimes you do have to check through the data that you collect. And now let's go over a conclusion for this video. So AI has a complicated terminology when people throw out terms like AI, machine learning, data science. So in our next video, we're going to share with you what these terms actually mean so that you'll be able to confidently and accurately talk about these concepts with other people. So thank you so much for watching from Try to Be Useful, and we'll see you guys in our next video.